So in this part, we will try to resolve the problem for those coefficients. Okay. Suppose that we have to expand x plus y power n. Okay. So based on my logic, how we will write down those things? We will be writing x power n and then y power 0 plus x power n minus 1 y power 1, x power n minus 2 y power 2, x power n minus 3 y power 3. Okay, and we will keep on doing this thing till we get x power 0 and y power n. Right now we have only one hope to find out its coefficient, and that is Pascal triangle. Okay, now look at this. Now I will tell you one thing, like just write down that Pascal triangle one more time. So it is 1 1 1 1 2 1, then it is 1 3 3 1 1 4 6 4 1 1 5 10 10 5 1. So it will keep on going, and you know that if the power is n, we will take help of n plus 1th row. Okay, now look at this. You know that we will not do this kind of mazduri till n plus 1 time. Okay, so how we will resolve this problem? So we will resolve this problem by taking help of NCR. Okay, so what does this NCR means? Try to understand this part. So first it is N, it is C, and then it is R. Now try to understand what is this NCR is. So it is, if you want to open this part, you can write it as n factorial by r factorial into n minus r factorial. Okay, for domain you can say that n belongs to natural number. First it is n should be natural number, r should be whole number, okay, and n should be greater than or equal to r. So this is domain. Okay, now how we will get the coefficient of this terms? So the idea was, just look at this. If you want to find out coefficient of first term, go with NC0. If you want to find out coefficient of second term, go with NC1. Third term, NC2. Fourth term, NC3. And the last term, NCN. Okay, now look at this. Just try to connect yourself with this explanation. Suppose that we are interested in finding expansion of x plus y power 2. So it should be x square y power 0, x power 1 y power 1, and then x power 0 y power 2. If we will talk about the coefficients, it should go like 2c0, 2c1, and 2c2. Correct? Now let's simplify this thing. 2c0. So it is 2 factorial by 0 factorial into 2 minus 0 factorial. So it is 1. 0 factorial is 1. Now 2c1. So 2 factorial by 1 factorial and to 1 factorial. So it is 2. 2c2, it is 2 factorial by 0 factorial and 2 factorial. So it is 1. So the idea is it is x square plus 2xy plus y square. So this is how we have resolved the problem of those coefficients. Now look at this. Now you have to observe something. Okay, so some observation you have to write. Okay, now try to observe this part. Just focus on number of terms. Okay, so suppose that the power is 0. So if power is 0, you know that you will be taking help of first row. So in first row there is one element. So if you will expand x plus y power 0, it will become what? 1. Number of term will be 1. Now x plus y power 1. So you will have two coefficients. So this means you will have two terms. Power is 1, term is 2. If power is 2, the number of term will be 3 because there are 3 coefficients. If power is 3, number of term will be 4. So can I say that the number of terms will be 1 greater than the power? Okay, so the number of terms will be n plus 1. Okay, now observe second thing. Sum of powers of variable. Sum of powers of variable. Now look at this. If you will add this, it will become 1 n. If you will add this, it will become 1. If n. If you'll add this, it will become n. If you'll add this, it will become n. If you'll add this, it will become n. So can I say that sum of powers of variable is n? Okay. Now look at this. Next thing. Can I say that the coefficient will be symmetric from start and end? Look at this. Start is 1, end is 1. Second term is 3. Second last term is also 3. First term is 1. Last term is also 1. Second term is 2. 4. Second last term is 4. Third term is 6. Third last term is also 6. Okay. So can I say that coefficients are symmetric from start and end? Can we say this? Correct now? Now try to observe your rth term. Okay, so suppose that now look at this part. Okay, so I am interested in finding the rth term. So the idea is, look at this part. First look at that n. So nc is everywhere. Nc is here, nc is here, nc is here, nc is here. So nc is everywhere. So can I write rth term? You are not supposed to memorize this thing. Okay, just try to observe. Okay, and then I'll connect the dots. So nc is common, so just write nc. Okay, now write x. Okay, and then write y because both variables will be there. Okay, now try to observe the lower subscript of c. So if it is first term, the lower subscript of c is what? 0. Term 1, 0. Correct? Term 2, it is 1. Okay, term 3 it is 2, term 4 it is 3, correct? So if it is term r, can I say it is r minus 1? Means whatever term I am saying, you are saying a number less than that number, 1 less than that number. So if I am talking about first term, you will say answer as 0. Second term 1, third term 2, fourth term 3. So you are always answering 1 less than the number which I am quoting. Okay, now look at this part. Now try to observe the power of y. So can I say that the lower subscript of c and the power of y are same thing? Correct na? Here 0, here 0, here 1, here 1, 2, 2, 3, 3, n, n. Correct? So can I write r minus 1 over here? Correct? And based on this thing, the sum of powers of the variable is n. Okay, so right now I don't know what will be the power of x. I'm assuming x power will be z. So z plus r minus 1. So I am adding power of x and power of y, and it should come out to be n. So z will be what? N minus r plus 1, n minus r plus 1. So if you will add, you will have n. Okay, so this is the nth term. Okay, now this is our 4 observation. Now look at this. They are saying that the third observation, just read that again. So in third observation, it is being quoted that coefficients are symmetric from the start and end. So can I say that NC0 will be equal to NCN? NC1 will be symmetric as NCN minus 1. NC2 will be same as NCN minus 2. Or can I say that NCR will be same as NCN minus R? Just tell me. Correct? So these results you have to digest. Okay, I hope the idea is clear. Okay, so what we have studied, the number of terms will be 1 greater than the power. Sum of powers of the variable will be n. The coefficients will be symmetric from the start and the end. And we have studied about rth term. Okay, so whatever may be the power of whatever may be the term, the lower subscript of c should be 1 less than that quoted number, and lower subscript of c and the power of y are same. Okay, and then manually you can find power of x. I hope the idea is clear.